Hello, I'm Gurnath Kadam and I will be presenting our work on randomized coalescing techniques in GPUs to mitigate the correlation timing attacks at HPCA 2018. Correlation timing attacks have been studied extensively on CPUs. In these attacks, the goal of an attacker is to find the correct encryption key on the server from the available key guesses. For this purpose, the attacker encrypts a plain text on the server under attack and records the resulting ciphertext and the corresponding execution time. The ciphertext helps to establish a relationship between the encryption key and the execution time. To find the correct key, the attacker must record the ciphertext and the execution times over a large number of plain text. Using the ciphertext and the execution times, the attacker can then find the correct key value from the guessed key values. Recently, GPUs have been shown to accelerate the encryptions on the servers. GPUs employ single instruction multiple data paradigm to enable fast and energy efficient computations. This helps to accelerate the cryptographic algorithms. The question then arises if the GPUs are vulnerable to the correlation timing attacks. Previous work has successfully demonstrated a correlation timing attack on the GPUs. The key idea exploited by this attack is that the AES key helps to determine the last round memory accesses generated by the table lookups involved in the AES encryption. These memory accesses are coalesced together deterministically in the GPU and therefore can be calculated correctly by an attacker. Since the number of coalesced accesses affect the execution time, the attacker can recover the AES key by correlating the number of coalesced accesses calculated by her and the execution time. In our work, we introduced randomized coalescing mechanism RCoal to mitigate the correlation timing attacks on the GPUs. With RCoal, our goal is to make the calculation of coalesced accesses harder for the attacker. We proposed 3 novel coalescing mechanisms that randomize the size, number, and thread elements of a subwarp. The size and the number of subwarps provide the granularity to determine how many memory accesses are coalesced together. Our results show the RCoal improves the security by 24 to 961 times at a nominal performance loss of 5 to 28%. For further details on our work, please attend my talk during session 3A in Europa 4 Hall. Thank you.